When you brought up ITAR and technology, will you please explain to me how, like the mission profile of how the rocket plane is take off? Is it going to be a horizontal takeoff from a runway, or will it be vertical launch?
Oh no, we're very much of the wings are good for space religion, and there's definitely other opinions on that. But the rocket plane is a one-piece ship with jet plus rocket engines on board the same vehicle. So we take off from a conventional runway under jet power. We have two afterburning turbojets. It's the J85 GE turbojet, which is the engine that's on the F5 and the T-38. So it's the right size engine for what we need, is the right amount of thrust, really good thrust to weight. Even though it was originally built in the 60s, it's very reliable and is supported all over the world, because the F5 is still a frontline fighter in some parts of the world, and the T-38 still the supersonic trainer for the U.S. Air Force as well as for NASA. And so it's a good engine for us. We take off under jet power. We fly downrange about 80 miles and climb to about 40,000 foot altitude under jet power. Then the rocket engine lights up. Once the rocket engine is confirmed as being a healthy start, then the jet engines are shut down. You do a 3G pull-up to a 70 degrees nose-up attitude. You have about a minute and a half of rocket burn under the main rocket thrust. Main engine cuts off at about 150,000 feet, and then you have the ballistic coast over the top to get to the 330,000 foot, 100-kilometer astronaut line. Come back down, about 4 minutes of zero gravity over the top. I mean, all the vehicles are roughly the same, because the fundamental physics of a 100-kilometer lob is the same for anybody. The difference is in the details. We come back down. We exit the atmosphere at a 70-degree angle, which means that we have a horizontal component to the velocity vector. We re-enter at 70 degrees coming in the other way, and we're actively flying through the re-entry. The shallower altitude, so you're not coming straight down, reduces the G profile a little bit, so our peak Gs are at about 4 instead of the 6+ for the vertical re-entry guys. We decelerate from Mach 3.5 to subsonic in about a minute, level out in a subsonic glide at about 60,000 feet. Gliding back to the spaceport, we do an air start on the jet engines at 20,000 feet, and so we come back in for a powered landing. There's fuel on board for the jet engines, and so we have a powered landing with the jet engines on.
Now, what type of rocket engines would be used? Would it be solid, liquid, hybrid?
No, liquid. The gas and go is the only model to really talk about it all. So in that case, we're of the same mind as X-Core. It's a liquid oxygen kerosene rocket engine. It's a 36,000 pound thrust, so it's a single engine, one big bell nozzle, regeneratively cooled engine. It's based on the Atlas sustainer engine. It's been, so the legacy design is from the center engine of the first stage of the Atlas, and the thrust has been derated in order to give it a longer life, and regenerative nozzle, and we're using more or less an off-the-shelf turbo pump that's made by Barber-Nichols that uses peroxide monopropellant to run, so it's a gas generator type turbo pump running the rocket engine. It's made by a company called Polaris Propulsion in California. These are legacy Rocketdyne guys. When Pratt & Whitney and Rocketdyne merged, the kerosene group within Rocketdyne, these guys, led by a guy named Dave Crisali, spun out and started Polaris. And so we've contracted with them, but these are people with 30, 40 years experience in LOX kerosene engines, and lots of flight time on the Atlas.
Have they already built the engine?
No, we had the engine had gone through critical design review. We were fabbing the prototype and some of the test articles when we had to shut everything down because of the money problems post COTS debacle. So that's one of the first things we have to do is restart, because the engine program is a critical path item, and we want to literally have hundreds of tests of the engine on the test stand before we put it in the vehicle and start powering it up.
So do you guys still have any of the old hardware before the merger with Kistler? What's the current status?
On the rocket plane side? Well, yeah, we do, but the bulk of the investment was really in the engineering and the IP, the wind tunnel testing, all of the 200,000 man hours of engineering time is all in the CATIA system. And with a modern aircraft, you build the aircraft virtually in the integrated CAD set and then start fabbing the parts once you have the whole airplane put together in the computer first. So all that data is still there, and is the first thing we do is we restart the program office.
So how much time then and how much money would be needed before you guys have flight hardware?
It's in the neighborhood of 3 years. We're going to try and do it a little sooner, but it's certainly years, and it's in the hundreds of millions. Don't want to be too specific for competitive purposes, but we're not in the tens of millions of dollars class like X-Corps and Maston and Armadillo are. We're in the same general order of magnitude as Virgin, although a little bit less. And we're certainly not in the investment class like what EADS Austrium is talking about with their Spaceplane, which is $1.5 billion plus. So, Austrium rolled out their Spaceplane in the summer of 2007 at the Paris Air Show with a cabin mock-up and glitzy videos and everything, and their expectation was kind of the same as ours, that you could go out and raise $1 billion in the Middle East. They were expecting that they would do their rollout at the Paris Air Show, and some buddy from the Dubai royal family was going to write them €1 billion check. Didn't quite work out. But they're still around, and they're still funding their program, and in a way we view that as a kind of a validation, because they essentially picked the same architecture we did as being the most reliable, safe and operable, and have the ability to actually fly from crowded airports. Because if you're gonna fly from places people want to go, you have to be able to operate within the air traffic control system, and you have to be able to respond to ATC commands, and coming back in as a glider is called an emergency landing in air traffic control terms, and they typically don't want to be dealing with that on a regular basis. So the one-piece Jet Plus rocket architecture allows us a lot more flexibility in terms of being able to fly from very interesting and attractive places that people would actually want to go to.